It seems simple enough. Unfortunately, this setup does not work that way. I have to turn on the light over there, and then come over and turn on this softbox, and then we get out the Nintendo Wii power brick to turn on the lights behind me. Of course, there's the one up above, and then around here, well, those are connected to this power supply. And when you turn it on, the fan is really loud, and it makes a separate high-pitched noise. I really need to build a light switch, a kind of complicated one. Let's do that. Technically, I could just get a regular light switch. They're in abundance. But then I was thinking I should be able to dim the lights. I've never needed to do it before. I probably won't ever need to do it, but it should have that feature. Also, preferably, I don't use the loud power supply or the Nintendo Wii power brick. Why did these stop working? Oh, that is burning hot. This is an interesting problem. Okay, so no light switch. Instead, I want to use this, a power MOSFET. Instead of physically switching my lights on and off, I want to use the power MOSFET, which you can switch on and off by providing a signal to its gate pin. A signal which could come from a variety of places. For example, a light switch. This is seeming redundant. Then we hand that signal wire over to a microcontroller that can switch it on and off very quickly, so it looks like the brightness is changing. The switches are decided on, but I still need to actually power the lights, which is where this comes in. This is the power supply from a small form factor Dell Optiplex. I chose this power supply because I had it, and it is powerful enough. Those were the only qualifications. To control my switches, I'm going to use this, a Raspberry Pi Pico. I've never used one of these before. I have a lot more experience with the Arduino family of microcontrollers, but I thought I'd try something different because they didn't have enough PWMs and I2C lines for everything. Oh, by the way, this is having an OLED screen on it. That was one of the reasons I needed this. I guess that brings me to my interface, which is going to be this tiny OLED screen, a power button, and a selector knob that will select my brightnesses. First things first though, how do I get power out of a Dell Optiplex power supply? These are not standard ATX plugs. I mean, this one is, but this is certainly not. Step one to getting power out has got to be putting power in, so we'll do that. And then something on here must turn this thing on. These pictures are not explaining anything. Okay, it's looking like the green wire connects to the ground wire, and that should make the LED come on. And yes, that does work. 12 volts here, 12 volts here. Does this only do 12 volts? I guess I've already run into an electrical oversight. This only puts out 12 volts. Normal computer power supplies have 5 volts and 3.3 volts. This does not do that, which means I need something else to power my Raspberry Pi. I could try to find a fitting plug for this connector. I think I'm just going to cut it off. Now touching these two together should turn on that light bulb. Yeah, that works perfectly. So the lights that connect to the power MOSFETs and that are going to be dimmable and stuff are these LED ones around here. I'm going to section them off so multiple different ones can be activated at different brightness levels. And this also gives me the option to have colored lights and actually be able to change the colors. I was thinking I might want to do that on these ones on the back, which I guess have stopped working. I think that Nintendo Wii power brick gave out maybe. Since I also want to control the AC lights, those two and this one, I'm going to put some AC outputs on it and use a relay board to switch those on and off. So all of this stuff needs to fit into some kind of enclosure that can attach to the outside of this box. I'm thinking this can hang off like the underside of the table, and I'll put a box on this side with the AC outlets over here and all the electronics mounted somewhere. We'll figure that out. Let's design a box. Whoa, that's cool. Spent a few hours staring at design software and I've come up with this. It has problems, I already know about them. The general thinking with this one is this is the high voltage part of the box, so my AC outlets will fit something like that. And then the wires for these can come through this hole and go into this side of the box, which will house the relay board. Something like this. And then I'll have this piece to cover up the high voltage side of the relay board. So all the high voltage is contained within this box, and the bottom part of this, and all of the low voltage electronics will mount onto this part. The microcontroller will screw in right here, and all of my MOSFETs will fit into these little channels. So with the main box and then this piece covering that, there'll be one final cover piece to go over everything. Something like that. The big hole is going to get this terminal block, and all of the low voltage lights will plug into these. Probably not rated for that amount of power. These are for speakers. I am bleeding. That's where the screen and the buttons and stuff are gonna go. Let's see if we can assemble this. Oh yeah, another thing I forgot about. I had designed a system on the back of this to mount it to the power supply, and then I realized it was gonna be hard to print, so I just cut it off in the software. And then I printed it without ever fixing that. Probably should have done something about that. Maybe we just drill some holes in this power supply. That's probably fine. Now the metal shards I got in here can short out the power supply, just the way I like it. I've added this wire that goes into this box to the high voltage AC input. Now I just need to add one more wire under this ground screw, so I've got a ground for my AC receptacles. I did some off-camera mining, and all of the simpler high voltage part of this wiring is done. I need to do the actual complicated part now, but the AC plug, the ground wire, goes to ground, ground of the outlets. The neutral wire goes to all of the neutrals, and then the live wire off of the plug goes into the relay boards, and then each of the 4 outlets connects to one of the relays, so this one should be connected here. And it is. And then over on this side, I've got the wires off the relay board running up to my Raspberry Pi Pico, which means if I plug this in, didn't explode, I can unplug my light from the power, plug it into one of the outlets on here, and it does nothing because the relays are not turned on yet. But we now have software control over this light. If I run this code, it does this now. It's just turning each relay on and off one by one, and one of those relays goes to my light up there. With all of that functionality working, it's time for the more complicated part of this project, which is making a screen and buttons and all of the low voltage power stuff work. Let's get started on that. I'm going to get my cover plate installed over top of the high voltage wires, so all of that stuff is protected and separated from my low voltage side. I was kind of debating on if I want to screw down the controller now or wait until all of the wires are on it, but I think I'm just going to do it now so I can start to actually manage these somewhere, because there's going to be a lot of wires in this thing. So when I was working on the design for this, I was thinking this power supply would output 5 volts on it, but it does not, which is why I had to add this voltage regulator, and I don't actually have somewhere to mount it, so I don't know where this is going to go. I mean, it can fit right here, but there's nothing to screw it into. All of these MOSFETs are just screwing into undersized holes printed into the plastic, which does work, but I made the holes slightly bigger than I should have. They should have been a little bit tighter to hold these better. The very left pin on each of these MOSFETs all need to get wired up to pins on the controller. This is really the kind of thing you'd use a printed circuit board for. Like, I just have these resistors soldered on top of the MOSFETs. This is not very serviceable in the future. If I want to take out a MOSFET, it's going to be a nightmare. The funny thing is, I could have designed a circuit board, and I don't think I would have even had to pay for it, because I've gotten emails from both of the 2 big DIY PCB companies, and yet I am doing this. This is undoubtedly more fun than building a PCB though, until something doesn't work, and then it's going to be bad. I just realized I've been locked in on just putting these pin after pin. That's not where they have to go. They have to, there's a ground in there somewhere. I gotta move these. Should be the last gate pin. I think it's time for a test. I've got this all plugged in, I've loaded some software on here, and now we should see each individual MOSFET channel fading up and down. So I've got an LED strip here, and I'll plug that in. Oh yeah, it works. I don't know why it's pulsing like that at the end, but it is working. Do they all work? That one works. That one works. That one works. That one works too. Yeah, that's all of them. I think this is all working. So what's even left now? I just need to connect those connections to my output block. Oh, the entire user interface, the screen and buttons and stuff. I need to do that, but this is good progress. I'm gonna unplug this before I touch it accidentally. I think that all of the interface stuff is connected. I need to figure out how to write software for this thing, and then it's testing time. And now I have this running on MicroPython. You can see the screen's on. It's flickery on camera. It doesn't actually look like that. I found a different example code for a rotary encoder, some hours of software development later, and I think that it's done. This is the user interface. You can turn this knob to select what you want to adjust, click it, and it'll start adjusting it. So this brightness will go up. I should probably plug a light in. So this is completely off, and as I turn this up, the PWM increases and the light gets brighter. And now I can plug in up to 6 separate lights. So I'll plug in 3 of these, and I'll plug in this LED strip for all kinds of lighting. So let's say I've got this dialed in exactly where I want it. All of the lights in here that are going to be connected to this can now be turned off with one button. Oh yeah, including the one up there that's plugged into the AC outlet. And then when I want to actually get in here and turn them on, one button, everything is exactly in the state that it was when I turned it off. And that includes when you disconnect the power cable and plug it back in. It remembers everything. And if I scroll down on this menu, it gets to the relays. These are the 4 AC outlets, each individually controllable. Off, on, off, on. That works perfectly. It is now time to try this thing with the actual lights in this room. This is channel 3. There it is. So I can set the lights behind me to whatever brightness I want. Channel 2 should be the ones facing the wall. Yep. Maybe I want these on 50% brightness and not full brightness. And then, of course, we've got the ones above. Usually I'd want these pretty high, I think. Maybe something like this. And then we come down to the AC outlets, and we've got that light, and the last one, that light. Everything works perfectly. This is so much better than the way things were before because it's not loud. It doesn't make a terrible high-pitched sound, and there's no fan noise. It's actually still quiet in here. This is a major improvement. Also, we don't have the fire hazard of the Nintendo Wii power brick that the tip was like shorting out on. Probably this is better. I've also freed up this thing in case I need a like 30 amp 12 volt power supply for something that can be loud. And yeah, final thing to do with this is to get some colored lights back here, because then I can use 3 of the channels for red, green, and blue and set the back part to whatever color I want. I think that's gonna be pretty cool. And I think that is it for the new lighting controller. If you like this kind of electronics video, a little bit different than what I usually do, maybe check out the one where I built the Fisher-Price controller into a modern, modernly compatible gaming controller. If you do want to see more of this DIY kind of video, let me know in the comments below. This thing's got all my settings saved, so it's safe to shut it off all at once. Thank you for watching.